Imagine trying to fill a glass of water from a pitcher, but you're blindfolded, and the glass is miles away. You have to rely entirely on a distant sensor to tell you when to stop pouring. This is the constant challenge of managing liquid storage at a massive industrial terminal. On a quiet Sunday morning, a fuel terminal looks peaceful, a city of massive white tanks holding millions of gallons of highly flammable liquid. To keep everything running, the facility uses a main control system, the factory's steering wheel, which manages the flow of product in and out of every tank. Every day, this system acts as the daily driver. It constantly adjusts pump speeds and monitors temperatures to keep the whole facility stable. However, there is a core vulnerability here. If this single, everyday control system glitches while a tank is filling, the facility has no automatic way to protect itself. If that main control system fails, the pump keeps running. The fuel creeps past that safe line and pushes into a critical danger zone at the very top of the tank. Far away in a control room, this failure triggers a critical safety alarm on a monitor. But the operator on duty is tired. They've been working 12-hour shifts for a month straight, and their screen is already buzzing with hundreds of minor, non-critical alerts. In that flood of noise, they fail to see that this specific alert is a major emergency. This is a failure of safety culture. When a company ignores small mistakes or hides previous near misses, it trains its workers to treat active alarms as nothing more than an annoyance. The fuel crests the top of the tank, cascading down the steel sides and rapidly turning into a heavy, creeping fog of explosive vapor. Relying solely on one control system and the attention of an overwhelmed human creates a situation where a massive explosion is eventually bound to happen. To prevent this, engineers install an emergency backup computer. If the main control system is the steering wheel, this is the facility's airbag. The backup must be entirely independent, with its own sensors, wiring, and brains, so a single glitch can't kill both. It stays quiet, waking only in extreme danger to forcefully shut down the entire facility. Keeping these systems separate is non-negotiable. If your car's radio and its airbag share the same broken computer, neither one is going to save you in a crash. But what if that vapor cloud catches fire? A wall of heat at the base of the tank would make it impossible for a worker to reach these manual valves to turn off the fuel. This is why facilities install remote emergency valves. Think of these as the facility's emergency brakes. These valves allow an operator sitting in a blast-proof bunker to instantly lock down the fuel lines with a single button press. These valves are designed to close rapidly and tightly, cutting off the flow of fuel and starving the fire before it can spread. Moving human operators out of the line of fire is the only way to guarantee the facility can be isolated quickly during a leak. Not every threat is as obvious as an overflowing tank. Sometimes a pipe develops a tiny, invisible leak underground, miles away from the terminal. To catch these, engineers use light-based tripwires. They take unused fiber optic cables, the same ones used for the internet, and turn them into a continuous sensor. A computer sends light pulses down the glass cable. If a pipe leaks, escaping pressure creates a vibration or cold spot, scattering the light differently. By measuring this, the system monitors miles of pipe and pinpoints the exact leak location. This technology gives passive steel pipes a nervous system, allowing the facility to feel damage and fix it before it ever turns into an emergency. When everything works together, the result is seamless. The light-based tripwires catch the leak, the backup computer overrides the failing main controls, and the remote valves isolate the fuel. The outcome isn't a dramatic explosion or a daring rescue. It is a quiet facility where nothing went wrong. Survival in these facilities depends on having completely independent layers of safety tech that stand ready to catch the failures of the daily operations. However, even the most advanced fiber optics and safety computers are useless if management refuses to listen to the data. Technology provides the warning, but humans have to provide the response. We know these engineering lessons are vital because we've seen the alternative. These safety standards were written in the aftermath of tragic, preventable fires. Physical safety systems are only half of the equation. A billion-dollar refinery is only as safe as the culture of the people who operate it.